So first off, thinking about what Ava just kind of described, what would happen to this graph, Peter? Right, so because of this number inside, the a you can think of as an x. So anytime you have something inside the absolute values with a, with x, whatever variable that happens to be, the graph is moving right. So this graph is moving right. The minus sign is part of the equation. The 60 is actually the direction that it's moving. So it's moving right 60. And then Peter said the vertex would be at 60, and then you said 0, Peter. Why'd you say 0? Yeah, right here. Usually there's a K sitting there, a number, a 5, a 7, a 15. Well, there isn't one. So that means the graph is not moving up or down if there's not a number there. So the vertex would be at 60 and then 0. So when you're graphing this, and you can use the same graph paper that I gave you for the other graphs, you can scale the graph, and instead of counting by ones, you can count by tens. You just need to list that to show what you are scaling your graph by. Or you could have counted by fives, but tens work a little nicer. So then the vertex is at 60, 0. So that's right there. And then, Peter, what's the slope of this graph? 1. So the slope is 1. Now here's the weird thing about scaling a graph. If you scale the x-axis, I strongly suggest you scale the y-axis the same exact way, because then your scales are the same. So if I scale the x and scale the y, when I count with my slope, I can count the same way, up to 60 here, as going up 1 and over 1. So if I go up 1 and over 1 in both directions, yes, I'm going up 10 and over 10, but 10 and 10 still makes a slope of 1. So if you scale your x and y axis the same exact distance, your slope remains the same. So I'm still rising 1 block and running 1 whole block. And then I can rise 1 block and run 1 block in both directions. Missed my point there. So this is what my graph would look like. It should be a V because there's absolute values. The graph should have a vertex at 60, 0. So anytime you scale a graph, keep your scales the same on the x and the y axis, because then the slope remains unchanged. The second part of this question, after you graph it, it says for what value or values will E, which is the error in the speed, God bless you, be 2.5 miles per hour? Bless you. What do you do with the 2.5 miles per hour, Chris? Yeah, because that's the number that they're giving us for E, so we can plug that number in for E, not 20. So take the 2.5, they're saying E is that number, so you're replacing that number into your equation, and then we have the absolute value of A minus 60. So in chapter 1, section 7, we talked about solving absolute value equations and solving absolute value inequalities. So you have to think back to like 2 or 3 weeks ago. Josh, how do you solve an absolute value equation? Yeah. So absolute value equations, when you get rid of those bars, that really creates 2 sides to your equation, because there are 2 sides to my graph. So I want to take into account that I have a left side of the graph and a right side of the graph, which is why I have 2 pieces of an equation. So 2.5 equals x minus 60, or a minus 60. One needs to be positive to represent the positive slope. The other one needs to be negative to represent the negative slope. And then Josh, if you solve both of these, by adding 60 to both sides, you end up getting 2 speeds of
62.5 and 57.5.
So the question says, for what values of A will E be 2.5 miles per hour? So 1 would be 57.5 miles per hour, and the other one would be 62.5 miles per hour. So that's saying the error in the measurement of your speedometer could be actually reading a little lower or a little higher. Your speedometer might say 60, but in fact, your car might be going 57.5 miles an hour, or it might be going 62.5 miles per hour. Because it might not be 100% perfect. So that's what the error represents. Questions? So I would like to take a peek at that homework. So if you make sure that your name is on the top. Did the stapler come around, everybody? Somebody have the stapler? Put up there. Here's the other one. Thanks. So today we are going to continue to look at graphs and transformations of graphs. So transformation is anytime a graph shifts. It could get wider because of the slope, like Ava had. It could get narrower because of the slope in front is a little different. But a transformation shifts a graph. It makes a graph wider. It makes a graph narrower. Or we saw that the graph could flip. So we're going to look at more transformations today, but we are going to look at transformations of general graphs as well. So in your packet, if you can flip to page 26. So this is actually something that you'll cover now. And then, crazy thing, in my honors sugar-free calc class, I'm going over it again with even more involved graphs. So literally, you do it now, this year, and the exact same time next year when you take on sugar-free calc. If you take on sugar-free calc, you'll be doing it again. So we cover it a lot. You should have done basic graphs and transformations in geometry and also in algebra 1. Now our goal is to kind of go beyond a general or an equation that you know and try and look at a more general equation. So this says the graph of A times f of x minus h. This is now function notation. That function represents any possible graph that could exist that is a function. So it doesn't just have to be absolute value like the absolute value graphs that we looked at. It could be any graph. So that's what that f means. Any kind of function that a graph is a function, passes the vertical length test, can be obtained from the graph of any function y equals f of x by performing these steps. So it says step 1, stretch or shrink the graph vertically by whatever the a value is. So Ava's problem had a 1/2, and we ended up vertically shrinking it, which means that the graph got wider. So it got squished vertically, so we call that a vertical shrink, or the graph truly got wider. Or we would vertically stretch it, and the graph got skinnier because the numbers were pulled more vertically because the number was bigger than 1. The second step says reflect the graph, which means if my graph is currently going up, I'm reflecting it and it's going down. Next year you'll also learn that a reflection can flip a graph left or it can flip a graph right. So sometimes they wouldn't be functions then, and we're right now working on something that is a function. And then the last thing it says to translate the graph. Translating means shift it left or right based off of the h value, or up or down based off of the k value. So there's 3 steps that we're going to think about: stretching it, reflecting it down, or translating the graph, moving it left, right, up, or down. So we are going to do 2 different types of graphs. And if you look at the first one underneath there, looks like part of an absolute value graph. There we go. But it isn't actually the whole part of an absolute value graph, so we have kind of 2 pieces of a line that create that line, or the graph, the 2 lines that really create this graph. Maybe. There we go. So we have this function. It has a point on the y-axis at 0, 4, and then this is one piece of a line. It stops at the vertex, this lowest point. And then I have this other portion that goes then from the lowest point, the vertex, and it continues to move outward. And that one goes on forever because that has a little arrow on it. So it says that we have this function f of x. It doesn't actually get an equation. We'll talk about writing the equation for that function on Wednesday. But right now we just have this graph, f of x. And our goal is to graph part A, which is 1/2 of f of x, and then part B says negative f of x plus 1, and then plus 2. So that's going to be our goal. The first thing that I'd like us to do before we talk about graphing, we're actually going to graph last. So I'd like you to find a couple of points or write a couple of points that go along with this current graph. So we're going to make a t-chart. So I'm not doing anything with A or B quite yet. I want you to make a t-chart and pick a couple of points that are on the graph and list them in the t-chart. So my first point moving from the left is at 0, 4. We have a point at 1, 1, and then 1, 2, 3, 4, 4, 3. And those are the 3 points that are given. So I'm just writing those 3 points again. So this is like a little bit of work that I'm showing to try and think about how I'm supposed to transform this graph or sketch the new graph. So our first graph says y equals 1/2 f of x. What the heck are you supposed to do to get that to graph? What does that mean? Nick. So he said multiply each point by 1/2, and I'd say you're almost correct. What part of the points are you going to multiply by 1/2? Because we have an x and a y, so we're going to do both of them, or are we just going to do one of them?
Both.
Why do you think both?
Because you shrink one to the other, you move one to the other to move the other.
Not necessarily. Jack, what do you think?
Multiply the x by 1/2.
Chris, what do you think?
Multiply the y.
Why? Because nobody else said that one. Nina, what do you think?
I think it's the y because you multiply fx by 1/2 is y.
Right, f of x also means y. So when you say f of x, the notation of f of x is the same thing as y. F of x equals y equals f of x. So your y variable is also f of x. F of x just means we have a function. Y doesn't have to be a function, it can be any random equation. But they are the same thing. So this is saying you're taking 1/2 times all of your y values. That's what that equation is really saying. So 1/2 f of x really means I'm going to make a new t-chart. My x is staying the same, but I'm taking half of y, and only the y. Because x inside the parentheses, this guy right here, it's just x. It's all by itself, just written as x. So x isn't changing because there's no numbers inside the parentheses with x. So keep your x values the same. We have a 0, a 1, and a 4. And now we're taking the y values and cutting them in half. So we had a 4, now it's a 2. We have a 1, now it's a 1/2. We had a 3, now it's a 3/2. These are going to be the new points that we graph for this function. So we should see a vertical shrink in the graph because we cut all the y values by 1/2. So taking these new points, we have a 0, 2. At 1, we're only going up to a 1/2, and then at 4, we're going up to 3/2. And you can look at the original graph and look at the new graph and see that it has shrunk vertically. So we call this a vertical shrink. That's what the 1/2 has done to it. So the x values stayed the same. I still moved over the same amount. But now comparing it to the original graph, it does look shorter than the original graph. So we're going to see if we can do part B. And that equation says negative f of x plus 1 and then plus 2. And we're going to make a t-chart again to try and do some work. So we're going to do a little work before we graph it. And that's what I'm asking you to do in some of your homework problems. So 19 to 24, I want to see the t-chart first, and then for you to plot those points from the t-chart. And we'll go over that when I give you out that worksheet. So let's make a little t-chart. In the t-chart, I'm going to show like what I'm doing to the problem. So if you look at the notation, I know it looks weird to have an f in front. But start on the inside with x. How would this graph shift if it says x plus 1, Peter? It shifts to the left. So this graph goes left 1 unit. So if it's moving left 1 unit, Peter, what does that mean we're doing with the x values if it's moving to the left? Subtracting 1. So up in my t-chart, I'm going to write x minus 1 so that I know what I'm doing with x. So even though there's a plus 1 inside there, that's really x minus a negative 1. And that negative 1 tells us the graph needs to shift left. To get my x to do that, I'm going to subtract a value from my x. What else is going on with this graph? Peter, what else? Yeah, so this plus 2 makes the graph go up 2 units. And then the last thing, there's a negative inside, or out front, I should say, not inside. Nina, what's that negative do?
Makes the graph upside down.
Yeah, it's going to flip the graph. It's going to make the whole thing go upside down. So it's moving up 2. That means my y value has to increase by 2. The negative sign is in front of f of x. So that means the negative sign is going to go in front of my y. So I'm taking negative y because it says negative f of x, and then we're adding 2. So we're making y negative, and then we're adding 2. So that crazy notation is saying the graph is flipping. Well, if the graph flips, that means my y has to be negative, and the graph is also moving up 2. That's what's happening with y. So go back to your original points, and maybe work on the x first. Do one at a time. So the x value, we said graph is shifting left. So I'm going to take the x values and subtract 1 from each x value. That's how a graph shifts left, by subtracting 1 from x. So x is now negative 1, 0, and positive 3. So we subtracted 1, which is really shifting the graph left. The y values, I need to plug in or make the y negative and then add 2 to the value. So I had a 4, now it's a negative 4, and then I need to add 2 to it. So I need to make it negative first because multiplication comes before addition or subtraction. So I'm making the number negative and then we're adding 2. So Nina, if I make my 4 value negative and then add 2 to it, it becomes
Negative two.
-2. So this is now a -1 plus 2, so my new point would be
Wait. For which one?
this guy right here.
Oh.
So make it negative and then add 2.
Oh, one.
Yeah, it stays the same. Make this negative and then add 2. Good. So I took the current y value, this was our original set of points right here. Made it negative first and then added 2. So now if you go to plot these new points, I have 3 points to graph. Connect them in the same way. So my graph flipped upside down. And then it also shifted. So after it flipped upside down, it shifted left and it shifted up. The up part's hard to see because it's flipping upside down as well. So that part's a little harder to see. Questions? They're tricky. So I believe there are 3 other graphs. So it says describe the transformation and then sketch the graph. And this one, we just have 3 points here. Doesn't extend on forever, it stops at the first point, the last point. We have that second point in the middle there. So start by making a T-chart just for the graph that you currently have. And they give you the points, so I'm just going to kind of plot those or write them again in the T-chart. Then we're going to describe the transformation. So how is this graph moving? So that F part, don't let that get you confused. That just refers to the graph that you're given. Think about what happens inside with X, what happens outside with the -3. Ava, do you have an idea of how this graph is going to shift?
You're going to add two or subtract two.
Yeah, so really this is X minus the -2. So she said we're going to subtract 2. And then what's happening with the Y?
You're going to subtract three.
Right, we're going to subtract 3 from Y. So here's my original T-chart. I'm going to make a new one for part A by using the rules that she just gave me. So left 2 or subtract 2 from X. Down 3 or subtract 3 from Y. So take your current X, the original X, subtract 2. Take the original Y, subtract 3. And then that's going to be the new graph that you're plotting. So it's still 3 points. And try and connect it as the given graph. So the given graph is going to look a little bigger because your graph, I think, is a little smaller. The little boxes are closer together. But it should still look like the same shape. So you have a ton of space underneath there. Make your second T-chart. Describe the transformation first so that you're actually thinking about what's going on with this problem. Michael, what's going on with this problem? So what's the 2 do in front? What's that going to make? Change. How's that going to change the problem? Yeah, so it's going to take 2 times y. Make some room for my T-chart down here. So 2y, We call that a vertical stretch. So that number there is a vertical stretch. What else happens, Michael? So how is the graph moving if it says x minus 4? Is it shifting left or is it shifting right? Say it again.
Right.
So the graph is shifting right 4. Because really it's just that positive 4. The minus is part of the equation. So x plus 4. And then one other thing, Michael, that's going on with this graph.
Plus
Not plus 4 on the y, but plus, yeah, it's moving up 1. So I need to add 1 to the y. So the 1 outside moves the graph up 1. So using the original point, we're going to move it right. All the x values need to be increased by 4 to get the graph shifting right. See if you can come up with those new ordered pairs. The y value, you need to double y and then add 1. So you're taking 2 times y and then adding 1 to it. Oh, what do you have for your first ordered pair that was negative 2, 3,
2, 7.
2, 7? How about the next ordered pair that was 1, 2?
5, 5.
And the last ordered pair was
6,
2, 0, and it's going to be
6,
6.
1.
You said, would you say 1 first?
Yeah.
Okay, so the y value, you're doubling it and then adding 1. So 2 times 3 is 6 plus 1. 2 times 2 is 4 plus 1. 0 times 2 is 0 plus 1. So check those values, make sure you have the same. So doubling the y and then adding 1. And then you're graphing those new points. So kind of comparing it to the one that we have right next to it, you can see that the graph got bigger. So the graph stretched more vertically. It's called a vertical stretch. So see if you can do the last one, describe the transformation, get that T-chart. I'm going to pass out your homework and I'm going to start one of the problems similar to this on the homework. So think what happens with X, what happens with Y. So Sadie, what's going on with this graph for letter C?
Doesn't it get reflected?
Yeah.
Moves down
So reflected because of the negative. That means it was up, it's going down. And she said it also moves down too. Is anything happening with X, Sadie? No. Inside, it's just X by itself. So it just has a little X inside. That means X isn't changing. It's just going to stay as X. So in the T-chart, you just have an X there. We're reflecting Y, so that means Y is negative, and then it's also moving down too. So X stays the same, negative 2, 1, positive 2. y is going to become negative, and then it also moves down too. So Sadie, the new y values would be, nice job. So x isn't changing. The y values are becoming negative because it's reflecting, so it's going downward. And then we're also subtracting 2 from that. So in this case, our graph has flipped. It is now kind of opening the other direction. Our original graph kind of was opening down, and now it's kind of flipped to go up. They're tricky. It's kind of weird when you don't even have like a normal graph that you know how to graph to begin with. Questions? So the worksheet that I handed out to you, you're going to do the evens on the front. So all of the evens on the front, 2 to 18 even. I would like to start you off with the back problems. We're doing all of the back, the evens of the front. And I ask for a T-chart for the problems on the back. And I'm going to start you off with just number 19. So it says sketch f of x, then sketch the function y given the transformation. So they give us this equation right here, x plus 2. And I'm just going to sketch it up in the margin. I'm going to make myself a little graph, trying to make it slightly neat so that we can pull some points for it. So placing a couple little tick marks. How would you graph x plus 2? Did this back in chapter 2. Peter, how would we graph that? Yeah, so begin with b. This is mx plus b form. So the y-intercept is 0, 2, and the slope would be 1. So I would move up 1, right 1, or down 1, left 1. And then just like we did with the 6 examples, why don't you grab 3 points from that line? So I would say get the x-intercept, get the y-intercept, and then maybe just get a 3rd point. So my x-intercept is crossing at negative 2, 0. The y-intercept is 0, positive 2. And then pick one more point. So maybe we'll go 3 for x, comma 5, the point that I have up top, or 2, you could use a 2 for x if you wanted to. 2, 4. Maybe we'll use a 2. It looks like my x goes, might be all right. If we want to use 2, 4, 3, 5, either one of those is fine. So looking at number 19, it says take f of x plus 1. So think what's happening with the graph. How is it moving? Well, this graph is moving up 1 because it says my f of x, my equation, my f of x, my y, and then I have plus 1. So in your little T-chart, the x is staying the same, but you're adding 1 to y. So take your original ordered pairs and add 1 to all your y values. Nothing is happening with x. And then I would plot that new graph. It should still be a line. So the graph isn't changing, the shape of the line isn't changing, it's just my points should be increased by 1. So there would be my new line, just to kind of compare so you can see what the old line looked like. Old line is right next to it. Questions? Anybody interested in doing 23 or the word problem? Nick, you'll do 23. Alyssa, will you do the word problem, Alyssa? Yeah. Have a fantastic day.